Now next topic is topic number 4.5.3. This is normally known as overlapping of atomic orbital. So whenever we can say that bond formation will start between two either same or different type of orbital, here one of the most important concept is overlapping. Clear? Here one of the most important concept is, again we can say that overlapping. So generally S orbital is there in case of P, Px, Py and Pz will be there. Here overlapping will start. There we can say that distance between two orbital will decreases. As we can say that distance between two orbital will decreases. Here we can say that bond formation will start here. Clear हुआ? तो चलो तो यहाँ पे हम लोग डिस्कस करते हैं. See, तो overlapping of atomic orbital. तो when two atom come close to each other, देखो, when two atom come close to each other, so there is overlapping of atomic orbital. This overlap may be either positive, negative, or we can say that zero. So whenever overlapping will start, it may be further divided into three parts, either positive, negative, or zero, depending upon the property of overlapping. Depending upon the properties of overlapping of atomic orbital. Correct? When two atoms come close to each other, so there is overlapping of atomic orbital, and this overlap may be positive, negative, or zero, depending upon the property of overlapping of atomic orbital. Clear? The various arrangement of S and P orbital resulting in positive, नेगेटिव एंड जीरो ओवरलैप. क्लियर? P में क्या होता है? Px, Py and Pz will be there. Again I am repeating, the various arrangement of S and P orbital resulting in positive, negative and zero overlap are depicted in below figure. Clear हुआ? Now the criteria, अब यहाँ पे याद रखने का, the criteria of overlap is the main factor for the formation of covalent bond applies uniformly. Here we can say that uniformly to the homonuclear or heteronuclear diatomic molecule and then after polyatomic molecule. The criteria of overlap as main factor for the formation of covalent bond apply uniformly to homonuclear, heteronuclear, diatomic molecule and polyatomic molecule. अब आपको पता होना चाहिए what is homo, then after di, and then after we can strike as well as polyatomic molecule. Clear? Now in the case of polyatomic molecule, जैसे polyatomic किसको लिया हम लोग ने, like methane, ammonia and water, the valence bond theory has to account for their characteristic shape as well as. Clear? In case of CH4, ammonia and water, we are applying here this valence bond theory to identify, here we can say structure as well as we can say that characteristics. तो heteronuclear molecule का example कौन है? Methane, ammonia and water. ऐसे तो बहुत सारे example होते हैं, but here we are taking only these three. Now we know that shape of methane, ammonia and water molecules are tetrahedral, pyramidal and band shape. Clear हुआ? The shape of methane is tetrahedral, ammonia is pyramidal and H2O is band shape. It would be therefore interesting to find out if this geometrical shape can be explained in terms of orbital overlap. तो आपका जो shape होता है वो कैसे पता चलता है? On the basis of, we can say that here means orbital overlapping. Clear? On the basis of orbital overlapping, here arrangement of atom in this space will be again take place in such a way that कि chances of repulsion will be maximum. तो चलो पहले मैंने मीथेन लिया, तो मीथेन मतलब कार्बन है 1s2 2s2 2p2, यहाँ हीलियम ले लिया 2s2 2p2. तो this is electronic configuration in ground state. तो this one is electronic configuration in ground state. Excited state में one electron will jump from 2s orbital to 2pz. ये आपका excited state हो गया. Clear हुआ? Now अब क्या होगा? The energy required for this excitation, मतलब whenever you are interested to jump electron from 2s to 2pz orbital, then here we can say that energy is required. The energy required for this excitation is compensated by release of energy due to overlap between orbital of carbon and hydrogen. Again I am repeating, the energy required for this excitation is compensated by the release of energy due to overlap between the orbital of carbon and hydrogen. The 4 atomic orbital of carbon, see, 4 atomic orbital of carbon, each with an unpaired electron, can overlap with 1s orbital. Here 1s orbital of 4H atom which are also singly occupied. Here we can say that which are also singly occupied. So this will result in formation of 4 carbon hydrogen bond. Clear? In case of methane, what will happen? So 4 orbital of carbon will combine with, we can say that, 4 orbital of hydrogen, and whenever combination will take place, then 4 carbon hydrogen bond will be there. Clear? जैसे देखो ये कार्बन है, तो Z is 6, तो 1H2, 2H2, 2P2, ये आपका 1, 2, 3, here 2, ये 1 electron will jump from here to here, तो 1, 2, 3, ये आपका 1, 1, 1 will come. अब आता है हाइड्रोजन. नाउ सी, ये हाइड्रोजन में क्या है? तो Z is 1, 1s1, तो हाइड्रोजन 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 हाइड्रोजन, यहाँ पे देखो sp3. तो how many we can say that carbon hydrogen bond will form? Here we can say that, see, 4 carbon hydrogen bonds are there. Here 1 carbon, 2 hydrogen is present on this plane, and this is in front of this plane, इसको wedge बोलते हैं, and this one is dash, so it is, we can say that, back side of this board. Clear? Now it will, however, we observe that, see, while the 3p orbital of carbon are 90 degree to one another, and the HCH angle for these will be also 90 degree. So that is 3CH bond will be oriented at 90 degree to one another. Why 3CH bond? So this is related with respect to px, py, and then after pz. Clear हुआ? Now अब देखो, so here we can say that 2s orbital, now 2s orbital of carbon and 1s orbital of hydrogen are spherically symmetrical. So why it is spherically symmetrical? So because shape of s orbital is spherical in nature. So 2s orbital of carbon and C, so this is, we can say that, 2s orbital of carbon and 1s orbital of, we can say that, hydrogen, है ना? So 2s orbital of carbon and 1s orbital of hydrogen are spherically symmetrical and they can overlap in any direction. Therefore, the direction of 4th CH bond cannot be ascertained, and this description does not fit in with the tetrahedral HCH angle of 109.5 degree. So clearly it follows that simple atomic orbital overlap does not account for the directional characteristics of bond in CH4. क्लियर हुआ कि नहीं? समझ में आया? मतलब ये जो s और s, 2s orbital of carbon and 1s orbital of hydrogen, using similar procedure and arrangement, same, using similar procedure and argument, it can be seen that in case of ammonia and water molecule, the H and H and HOH angle, angle, here we can say that HNH and HOH angle should be 90 degree, but this is in disagreement with the actual bond angle, which is 107 degree and 104.5 degree in case of ammonia and water molecule respectively. अगर जैसा मीथेन में आपको मैंने बताया, same condition will come in case of, we can say, ammonia as well as water molecule. चलो, तब है ना, इसमें भी 90 डिग्री नहीं है, इसमें अमोनिया में वाटर में, तो वहाँ पे एंगल क्या है? In case of ammonia 107 degree and in case of water 104.5 degree will be there. Clear? Now we can explain positive overlap, negative overlap and zero overlap. यहाँ पे see here three figures are given. देखो PZ ऑर्बिटल है तो प्लस एंड प्लस, तो here chances of repulsion will be more. Here chances of repulsion will be more. Therefore we have to supply more amount of energy. Then positive overlap is possible. Other figure is related with PZ and S orbital, Py and Py orbital, Px and Px. मतलब see positive overlap can be explained between PZ, number 2, PZ and S orbital, Py and Py, and Px and Px. So this is complete information of positive overlap. Now second one is negative overlap. तो नेगेटिव में देखो PZ का प्लस है और ये PZ का माइनस है. Then after PZ and S orbital, Px and Px and Py and Py orbital is there. Clear? Then third one we can say that zero overlap. So zero overlap is possible between Px and S, and in case of zero overlap, here node is there. Here we can say that node is there. Node, है ना? तो node मतलब point at which to find out electron possibility will be zero. And then after ये देखो आपका ये ऑर्बिटल दिया है PZ वाला. मतलब see, तो for positive overlap, 4 pairs are there. PZ and S, Py and Py, and Px and Px. Similarly negative overlap, तो PZ ये देखो positive negative ले लेगा. Here PZ and S, Ps Py. Similarly zero overlap, तो Px and S orbital, and here Pz and Pz orbital. तो आपका जो फिगर है ना, फिगर इट विल एक्सप्लेन कंप्लीटली ओवरलैपिंग ऑफ डिफरेंट टाइप ऑफ ऑर्बिटल. यहाँ पे देखो हम लोग ने हेटेरोमॉलिक्यूल में कौन सा लिया है, मीथेन लिया. ऐसे ही आपका अमोनिया आएगा. इन केस ऑफ अमोनिया, तो अमोनिया में कैसा आता है, सी फॉर एग्जांपल हियर वी कैन से दैट दिस इज अमोनिया. तो दिस वन इज अगेन वी कैन से दैट हियर मींस अमोनिया. तो अमोनिया में देखो नाइट्रोजन है Z7, 1H2, 2H2, 2P3, ये 1 2 3, यहाँ पे 2 1 1 1 will be there. Similarly here हाइड्रोजन, ये क्या आ गया, हाइड्रोजन Z is 1, तो 1S1, तो हाइड्रोजन हाइड्रोजन हाइड्रोजन. क्लियर? यहाँ पे कौन कौन सा 4 ऑर्बिटल, तो 2s 4 ऑर्बिटल ऑफ नाइट्रोजन. आउट ऑफ दिस 4, 1 is from 2s orbital. Second one is again we can say that Px, Py and Pz. It will overlap with 1s orbital of hydrogen. Clear हुआ कि नहीं? And here we can say that concept of lone pair will come. Here lone pair will be 1. Similarly we are taking another example of H2O. तो oxygen Z is 8. So here 1H2, 2H2, 2P2. Here 2P4 is there. So 1 2 3. So 1 2 1 2 3, and then after 4 is there. Here is what will happen. Here hydrogen, तो Z is 1, तो 1s1. यहाँ पे क्या आएगा, हाइड्रोजन हाइड्रोजन. Here 2 lone pairs are there. Clear? In case of methane, no lone pair is there. In case of ammonia, 1 lone pair is there, and in case of water, 2 lone pairs are there. So this will complete information of overlapping of atomic orbital. Correct? Topic number 5.4.5.4. So this is type of overlapping and nature of covalent bond. So whenever we can say that overlapping will take place between S and P orbital, here may different type of bond formation will be there. Clear? So these bonds are again we can say that either sigma bond or we can say that pi bond will be there. So what is sigma bond? What is pi bond? So that type of thing we will discuss right now with the help of figure. Clear? For example, types of overlapping and nature of covalent bond. You see, the covalent bond may be classified into 2 types. Covalent bond may be classified into 2 types depending upon the types of overlapping. Clear? So one we can say that here sigma bond, and second one is pi bond is there. So what is sigma bond? See, this type of covalent bond is formed by end-to-end or hand-on overlap of bonding orbital along the internuclear axis. तो दिस इज कॉल्ड एज हेड ऑन ओवरलैप, head on overlap, or we can say that axial overlap. So this can be formed by any one of the following types of combination of atomic orbital. Here you have to remember end to end. Clear? Now SS overlapping. So what is SS overlapping? In this case there is overlap of two half filled s orbital along the internuclear axis as shown below. So this is s orbital ये आपका ओवरलैपिंग, इसी को हम लोग क्या बोलते हैं, सिग्मा बॉन्ड. जितना मैंने रेड कार्ड किया ना, दिस इज नॉर्मली नोन एज सिग्मा बॉन्ड. नाउ हियर sp ओवरलैपिंग. So this type of overlap occur between half filled s orbital of one atom and half filled p orbital of another atom. Here s and p में overlap होता है, here sp orbital will be there. तो फिर से ये जो आपका overlap हुआ ना रेड वाला एरिया, तो this is normally known as sigma bond. Now next one, here we can say p orbital is there. Here means see orbital overlapping will take place between ss and then after sp. Now we will discuss here pp overlapping. So this type of overlap take place between half filled p orbital of two approaching atom. So p orbital and this is pp overlapping. ये जो आया ना, इसी को हम लोग बोलते हैं सिग्मा बॉन्ड. इन दिस वे वी कैन सी दैट इन एसएस ओवरलैपिंग, इन एसपी ओवरलैपिंग एंड पीपी ओवरलैपिंग, हियर वी कैन से दैट सी हेड टू हेड ओवरलैप इज देयर एंड दिस हेड, देखो ये हेड टू हेड है, ये हेड टू हेड है, ये हेड टू हेड है. सो दिस इज नथिंग बट इट इज नॉर्मली नोन एज सिग्मा बॉन्ड. नाउ सेकंड टाइप ऑफ बॉन्ड इज वी कैन से दैट पाई बॉन्ड. तो पाई बॉन्ड में क्या आता है, सी in the formation of pi bond, the atomic orbital overlap in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. Again I am repeating, in the formation of pi bond, the atomic orbital overlap in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. चलो p orbital here overlapping will start. तो देखो ये internuclear axis है, internuclear axis. यहाँ देखो क्या आ जाएगा, here parallel to each other, और वैसे देखो तो perpendicular to internuclear axis. Perpendicular to internuclear axis मतलब ये है ना, perpendicular to internuclear axis ये है. और parallel की बात करो तो this one is normally known as parallel one. Clear? Now orbital form due to the side-wise overlapping. Here orbital form due to side-wise overlapping consist of two saucer type charged clouds above and below the plane of participating atom. ये क्या है, internuclear axis के above and then after we can say that below is there. In this way, in case of sigma bond, three different type of situation will be there. Which one? SS overlapping, PP overlapping, and then after SP overlapping. While in case of pi bond, only we can say that one condition will be there. Here we can say that whenever we are comparing sigma bond and pi bond, the strength of sigma bond will be more. Strength of sigma bond will be more as compared to pi bond. तो pi bond मतलब it is one type of field, magnetic field जैसा होता है, ठीक है. तो this is complete information. आई बात सर में देख लो अच्छी तरह से.